Welcome, dear listener, to the Sleepless Academic. I'm so glad you've joined me tonight. Whether you're curled beneath a warm blanket, listening to the hush of wind through the trees, or lying still beneath the quiet pulse of the stars, this moment belongs to you. A moment to rest, to wonder, and to slowly drift into that liminal space where science and stillness meet. Tonight's journey takes us far, far back into the deep time of our very own planet, prehistoric Earth. We will travel through ancient fire, primeval oceans, and the long-forgotten landscapes of Earth before memory. We'll witness continents being born and broken. We'll meet the planet before it had a sky, before it had life, before it even knew how to be Earth. No pop quizzes here, no pressure, just slow, thoughtful wonder, just gentle words, and perhaps a few ancient truths to keep your dreams company before we drift too far into this misty realm of lava and stardust. I'd love to know, where are you listening from tonight? Is the sun still peeking through your curtains? Or is the moon standing guard, while the world around you falls silent? Pop a comment below if you'd like. I read every one, and they always remind me just how connected we really are, scattered across the globe, all of us quietly seeking comfort, meaning, and a little bit of peace. And if these kinds of cinematic explorations speak to your soul, please do give the video a gentle like and tap that subscribe button. That way, other fellow night thinkers can find their way to this shared sanctuary. Now, let the lights dim. Let the quiet hum of your room fade into the background. You're safe here. You're warm. Feel the quiet awe of it all. Let your breath slow, your thoughts soften. And when you're ready, we'll step together into a time before humans, before language, before the world had a name. Let us begin our journey through prehistoric Earth. Let us go back, not just thousands of years or millions, but billions of years, back to the very first flicker of Earth, before trees, before oceans, before the sky was blue. This is the story of our planet. Long before we arrived. Chapter 1. A pale blue dot in the darkness, Earth's fiery birth. To understand what Earth once was, we must first accept how alien it truly used to be. Imagine floating in the darkness of space, quiet, infinite, cold. Stars shimmer around you like distant lanterns, and in the vast nothingness a dense cloud stirs, made of gas, dust, and the lingering remnants of ancient stars long extinguished. This is where our story begins. Roughly 4.6 billion years ago, this galactic cloud began to collapse under its own gravity. It wasn't sudden. It was slow, powerful, inevitable. As it contracted, it spun faster, flattening into a vast rotating disk, the protoplanetary disk. At its centre, pressure and heat gave birth to a blazing new star, our Sun. But far from the Sun's golden core, other things were forming too, coalescing from rock, ice and metallic fragments. Planets. One of them would become Earth. But the Earth you know, the one of blue oceans, green forests and human memory, did not exist yet. Not even close. Back then, it was a violent, chaotic place. A molten sphere of half-formed rock, constantly bombarded by the debris left over from the solar system's formation. With each impact, the young planet grew in size, but in heat. These were not gentle collisions. Imagine a mountain-sized rock slamming into Earth at tens of thousands of miles per hour. The energy released would melt crust, vaporize oceans, and turn entire regions into seas of lava. This was the Hadean Earth, named for Hades, the ancient underworld, and for good reason. Its surface shimmered with rivers of molten rock, glowing orange and red like a planetary forge. Volcanoes erupted continuously, belching toxic gases into the thick, suffocating air. There was no oxygen, no water, no life, only fire, stone and smoke. And then something colossal happened. A planetary body the size of Mars, Thutsa, which scientists have named Theia, collided with Earth. It wasn't a glancing blow, it was catastrophic. The force of the impact shattered Earth's outer layers, sending molten debris flying into orbit. Much of it rained back down, re-heating the surface, but some of it coalesced in the sky and became something beautiful. The moon, our ever-present companion, a silver sentinel in the night, was born from this violent act, and it would go on to shape everything about Earth. Its tides, its tilt, even the rhythm of its days. In fact, Earth's days back then were only about 6 hours long. The planet spun much faster, wobbling chaotically without the moon's stabilizing pull. Now, pause for a moment. Picture this alien world. Stand on its surface, if you could. Beneath your feet the ground trembles with seismic fury. Above, the sky is not blue but a thick swirl of ashen vapour. There is no breeze, only scorching heat. No birdsong, no water, just the low, endless rumble of a planet forging itself in fire. And yet, this was the necessary beginning, a cosmic crucible, a stage being set. Because even here, in the chaos, in the ruin, the foundations of life were being laid. The molten earth held within it the raw materials of biology: carbon, nitrogen, sulfur, phosphorus, iron, water, everything we would one day become. And deep within its core something else had begun to stir. Heavy elements like iron and nickel sank inward, drawn by gravity, forming Earth's inner core. As it spun, it generated a powerful magnetic field, an invisible shield that would one day protect Earth from the sun's radiation. Without it, our atmosphere could never have formed. Life could never have taken hold. In this way, even the earliest movements of our planet, or even the fire and destruction that is, were not meaningless. They were steps, movements in a slow cosmic symphony, and Earth was still only warming up. Over the next millions of years, the planet would begin to cool. A fragile crust would form. Gases released from endless volcanic eruptions would create a dense toxic atmosphere, and then, astonishingly, it would begin to rain, not for minutes, not for days, but for millennia. Rain that hissed and steamed as it touched hot rock, rain that carved the very first valleys, rain that would eventually fill the first oceans. But we'll come to that soon. For now, hold this image in your mind. A planet newborn and blazing, spinning wildly in the dark, carving itself into something new. This was Earth, before us. Chapter 2. Oceans from Steam, the Rain That Built the World. The fires had raged long enough. After millions of years of continuous eruptions, collisions and molten fury, something on Earth began to shift. The planet, once incandescent and uninhabitable, was slowly beginning to cool. Not everywhere, not all at once, but enough for something astonishing to begin. The first raindrops. Is almost impossible to picture it. In a world of searing heat, ash-choked skies and glowing lava flows, the very idea of rain feels surreal. And yet, here it was, microscopic at first, vapour condensing high in the sky, struggling to survive the blistering heat below. The droplets would evaporate before ever touching the ground. But the planet was persistent and patient. For eons this process repeated itself, steam rising, condensing, trying again, and then one day it succeeded. A drop made contact, then another, then countless more. It began to rain, not a gentle drizzle or a soothing summer shower, but an unrelenting deluge, as if the heavens had cracked open and poured their weight onto the raw, scarred surface below. It didn't rain for days, not even weeks. It rained for thousands, perhaps millions of years. This was not a storm you could watch from your window. It was a planetary transformation. Every drop hissed into vapour as it struck the still hot crust, releasing steam in plumes that clouded the already thick sky. Over time, the surface cooled enough for water to collect, pooled in low valleys and shallow basins, then gradually formed rivers, lakes, and finally oceans. Yes, the oceans, the very ones that still rise and fall beneath the pull of the moon, the ones that cradle the coral reefs, the whales, the drifting jellyfish, the ones whose waves still echo with the rhythm of that ancient beginning. Billions of gallons of water now blanketed the earth. And it was here, in these warm, mineral-rich oceans, that life would one day emerge. But not yet. These oceans were not the serene blue expanses we know today. They were dark, acidic, and teeming with dissolved metals. The sky above them was still a dangerous blend of carbon dioxide, methane, hydrogen sulfide, and ammonia, so thick and alien it would choke modern lungs in seconds, and yet they were full of potential. Let us pause for just a moment and imagine standing at the edge of this ancient sea. The land is jagged and volcanic, the air heavy and warm. Thunder rumbles in the distance, echoing off the primeval cliffs. The sky is a deep rust-coloured haze, and beneath it, stretching to the horizon, are the waves. Strange, turbulent, but alive with chemistry. If you could walk into those waters, what would you find? Not fish, not plants, not even bacteria yet, but you'd find the building blocks, complex molecules beginning to form, shaped by lightning, heat, and the sheer patience of time. These were organic compounds, the precursors to life, amino acids, fatty membranes, sugars, chains of carbon that twisted and folded like nature's first attempts at architecture. And from deep below the ocean's surface, something even more miraculous stirred. Hydrothermal vents. Cracks in the seafloor where scalding water, rich in minerals, surged upward into the cold, dark ocean. These vents created extreme environments, places of sudden heat and chemical gradients, perfect for fostering complexity. Many scientists believe that life may have begun here, in the shadows of these undersea chimneys, in a place with no sunlight, no surface, and no oxygen. Life found a way to spark. But let's not rush there just yet. Instead, imagine what it meant for Earth to now have oceans. Water would become Earth's greatest sculptor. It would shape the continents, wear down mountains, and transport sediments across the globe. It would become the medium in which life could unfold. It would also become the memory of the planet, carrying dissolved elements, storing traces of early chemistry, reflecting the sky above. Without water there is no story, and yet, even in this triumph, Earth was far from peaceful. Volcanoes still rumbled across the landscape. Asteroids still struck with unpredictable fury. One such collision, a particularly large one, may have tilted the entire planet on its axis, giving Earth its seasons and setting the stage for climate rhythms that would one day nourish forests and freeze glaciers. But through it all, the oceans remained. They were Earth's first mirror. They reflected the deep red glow of the early sun. They whispered across jagged coastlines. They tasted of salt, iron, and fire. And in their depths, the very first chemical symphonies were just beginning to stir. It's strange to think how much of us, our bodies, our blood, our tears, are made of water. And that this water, this ancient element, first pooled on a planet that was once too hot to touch, too wild to survive. But Earth was changing, cooling, calming. It had oceans now. It had a magnetic field to protect it, It had the elements of life and the environment to nurture them. It was, for the first time, ready. So let us linger here by the shores of this ancient world. Let the sound of the waves, those first waves, carry us deeper into the story. A story that has no narrator but time itself. A story that will soon take us to the dawn of biology and the first glimmers of life in a lifeless world. But for now, let the water speak. Let the silence of the early earth wrap around you like a lullaby. And let's drift forward gently into Chapter 3. Chapter 3, The First Life, Sparks in the Deep. Somewhere in the deep belly of the ocean, in a place where no light ever reached, the impossible happened. Life began. It didn't start with a bang or a flash or a divine announcement. There were no flowers blooming or birds singing, no grand orchestration of beginnings. Instead, life crept into existence quietly, like a secret. It was small. So small, in fact, that it couldn't be seen with even the sharpest human eye. But it was there. At the edges of boiling hydrothermal vents, those undersea chimneys that spewed hot, mineral-rich fluids into the icy darkness, tiny, self-organizing molecules began to cluster. These weren't life as we know it. Not yet. But they were close. Fatty membranes formed bubbles that floated in the swirling currents. Inside them, strands of carbon formed loops, reacting, folding, unfolding again. Some of these loops began to copy themselves, imperfectly, but with just enough stability to endure. These primitive structures weren't alive in the way you are, but they were the prelude, the first whispers of biology in a lifeless universe. And then, perhaps after hundreds of millions of years of chemical trial and error, something crossed a threshold. A molecule formed that could replicate itself. A single-cell structure encased in a delicate membrane, capable of consuming energy from its surroundings, of growing, dividing, and, most importantly, evolving. This was Luca, the last universal common ancestor. Not a creature exactly, but a progenitor, the humble parent of all biology. You, me, whales, birds, mushrooms, coral reefs, ancient oaks, all of it traces back to this obscure beginning. And where did Luca live? Most scientists believe it lived in the deep sea, perhaps nestled inside the protective vents of Earth's early oceans. There it could feed off chemical gradients and remain shielded from the harsh radiation still bombarding the surface above. In a world still unfriendly to light, life began in darkness. It's a poetic thought, isn't it? That the very first spark of life came not in a sun-dappled meadow or a flowering garden, but in a shadowy world of heat and pressure. Life began not in comfort, but in challenge. It adapted. It found a way, and once it began, it never stopped. These early life forms were prokaryotes, single-celled organisms without a nucleus. They fed on the minerals around them. Some performed a primitive form of photosynthesis, capturing energy from sunlight that filtered down into shallower waters. Others used chemicals like hydrogen sulfide, iron, or methane to power their tiny metabolisms. They were microbes, invisible, seemingly insignificant, but they would go on to shape the entire Earth. Over time, some of these cells became more complex. They learned to live in colonies, to share nutrients, to communicate through chemical signals. They began to specialize, and most importantly, some developed a new kind of metabolism, oxygenic photosynthesis. This was one of the most significant revolutions in Earth's history, because it produced a byproduct that, up until then, had been relatively scarce in the atmosphere: oxygen. At first, oxygen was a poison. It was reactive, corrosive. Many early organisms died out when it began to accumulate in the oceans and atmosphere. But some survived, and they began to evolve ways to use this new molecule as a source of incredible energy. This led to the next great leap, aerobic respiration. Organisms that could breathe oxygen suddenly had more power. They could grow faster, move more efficiently, and build complexity. Life was no longer just clinging to survival, it was now beginning to thrive. But back then, this transformation was slow, painfully slow. We measure it in billions of years, not days or centuries. From the first cell to the emergence of complex multicellular life, nearly 3 billion years passed. Try to hold that in your mind. 3 billion years of microscopic life. No trees, no animals, no flowers. Just an endless sea filled with single-celled organisms, quietly rewriting the planet. They changed the chemistry of the oceans. They transformed the sky. They left behind fossilized remains, tiny stromatolites, built by layers of microbial communities, many of which still exist in parts of Australia and South Africa. If you visited Earth during this time, it would still look alien. The sky was tinted orange or deep red. The oceans were greenish black. Volcanoes still dotted the horizon, but beneath the waves, life was patiently building its empire. Let's imagine one of these early oceans. You're drifting near the hydrothermal vent. It pulses with superheated water, rich with hydrogen sulfide and iron. Surrounding it are dense clouds of microorganisms, swirling, glowing faintly, like bioluminescent ghosts. They feed, divide, mutate. Every few seconds a few die. Others survive and pass on small beneficial changes. Evolution is happening, but so slowly you'd need to pause time itself to see it unfold. And above it all, Earth is changing. The oxygen levels are rising. The continents still drifting are beginning to find form. The first supercontinents will soon begin to take shape. And deep within these waters the future waits, quietly, patiently. Because something remarkable is coming. Cells will eventually join forces. DNA will coil into complexity, and the blueprint for every animal, plant and human will be etched in the language of base pairs. But for now, Earth is still ruled by the invisible. And isn't it comforting in some small way to think that the grand story of life began not with dominance but with humility, with the tiniest of organisms quietly transforming a world? So tonight, as you rest, allow yourself to marvel at that strange sacred fact that you, your thoughts, your hands, your dreams, are the distant echo of a single cell formed in the warm shadows of an ancient sea, and that in your bloodstream, your breath, your biology, the memory of that first spark still lingers. Let us drift now, deeper still, toward the age when these single cells began to cooperate, when the blueprint of animals, plants and fungi was first drawn. Let's step softly into Chapter 4. Chapter 4, The Rise of Complexity, when cells joined forces. For nearly 3 billion years, life on Earth remained microscopic, a quiet drama unfolding beneath the sea with no witnesses but the rocks and water themselves. But then something radical happened. Two cells, once separate entities, came together not as predator and prey, but as partners. One absorbed the other, not to digest it, but to shelter it. And the one who was absorbed, it stayed. It became part of the host, an internal engine, a tiny powerhouse. This, scientists believe, was the birth of the eukaryotic cell. Unlike the simpler prokaryotes, these new cells had nuclei, tiny command centers that stored their genetic blueprints. They had organelles, compartmentalized structures like mitochondria that managed energy production, protein folding and waste. They were like miniature cities humming with order. The absorbed cell, likely a free-living bacterium, became the mitochondrion, the energy factory of modern animal cells. And in plant cells another merger followed. A second absorption gave rise to chloroplasts, which captured sunlight and turned it into sugar. These partnerships were revolutionary. Instead of just surviving, life could now build. With energy to spare, these eukaryotic cells grew bigger. They became more versatile. Some developed ways to move, waving tiny flagella or gliding across surfaces. Others evolved the ability to engulf food, store nutrients, or respond to chemical signals. And then came the next great transformation: multicellularity. At first it was simple. Cells stuck together after dividing, just clumps really. But over time those clumps began to differentiate. Some cells specialized in feeding, others in moving, others in reproduction. Cooperation became complexity. These early multicellular organisms lived in oceans and lakes. Soft-bodied and alien, they floated, swayed, absorbed, and grew. They left few fossils, but in the rarest of sedimentary rocks, scientists have found hints of them, strange frond-like impressions etched in stone. These are known as the Ediacaran biota. Some look like ferns, others like discs, others like ribbed pillows. We still don't know exactly what they were. Were they animals, fungi, a now extinct kingdom of life altogether? Their soft forms offer few clues, but they were the precursors, the rehearsal. The real explosion was just ahead, in the deep timeline of Earth, around 541 million years ago. The curtain rose on one of the most dramatic events in the history of life, the Cambrian explosion. Within a span of just a few tens of millions of years, a geological blink, Earth's oceans filled with a kaleidoscope of new creatures. Hard shells appeared for the first time. Eyes evolved, limbs, pincers, antennae, exoskeletons. Life didn't just adapt. It flourished in a dazzling array of forms. You would have seen trilobites, armoured arthropods crawling along the seafloor with complex eyes, or the surreal Anomalocaris, a metre-long predator with grasping appendages and a circular gnashing mouth. There were worm-like creatures with bristles, jellyfish-like swimmers, and strange spike-covered floaters drifting in the currents. It was a time of experimentation. Evolution ran wild, trying out countless designs, and many of them worked. For the first time, ecosystems formed. Food chains, predators, prey, scavengers, filter feeders. A web of life began to weave itself across the oceans, each strand dependent on the others. And yet Earth's surface still looked barren. The land was lifeless, just rock, wind, and the occasional algae mat at the edges of water. The atmosphere was breathable only to those with ancient lungs. There were no trees, no birds, no footsteps pressed into dirt. But that would change too, because even as the oceans buzzed with diversity, some forms of life were beginning to test the edges of their world. Tiny green organisms, algae and cyanobacteria, crept into shallow ponds and damp stones. Their photosynthesis released oxygen, enriching the air. Mosses, lichens and fungi began to colonize land, slowly breaking down rock into soil. Earth was preparing for its next transformation, the rise of plants. But that story comes a little later. For now, rest in the memory of those early oceans, vivid with creatures never seen before or since. An underwater dreamscape where nature learned to sculpt with muscle and bone, light and motion. Imagine it now as you drift. The shimmer of trilobites beneath a pale Cambrian sun, the swish of soft-bodied swimmers, the glitter of evolution in motion. Let's continue our gentle journey into Chapter 5, where the land awakens for the very first time. Chapter 5, when the land awoke, the Green Revolution. For billions of years, Earth's continents were lifeless deserts, bare, wind-blasted stone under a fiery sky. Rain fell, Rivers carved canyons, but nothing green ever grew. That changed in the Silurian period, around 440 million years ago. It began at the edges where water kissed the land. Tiny, thread-like algae and bacteria formed slippery mats along the shorelines. They clung to rocks, absorbed sunlight, and began releasing oxygen, just like their oceanic ancestors. Slowly, they inched inland, setting the stage for a quiet revolution. The first true pioneers of the land were plants. Not tall trees or fragrant flowers, but mosses and liverworts, humble, low-growing plants without roots or stems. They had no seeds, no flowers, just soft green bodies that absorbed water directly from the ground. But they were powerful. These early plants began to change the land itself. Their presence softened the soil. They held onto moisture, trapped sediment, and slowly over eons turned sterile rock into fertile ground. Then came a breakthrough: vascular tissue. With the evolution of xylem and phloem, tiny tubes that transported water and nutrients, plants could now grow tall. They no longer depended on staying low and wet. They reached upward toward the sun. Forests began to form. The first trees were not like today's. Many were relatives of club mosses, horsetails, and ferns, giants of their kind, some reaching 30 meters high. Their thick trunks were covered in scaly bark. Instead of seeds, they spread through spores released into the wind like dust. As these primitive forests spread, so did their influence. They absorbed carbon dioxide from the atmosphere and released oxygen. They cooled the climate, altered rainfall, and created new habitats. For the first time, land had shade, it had shelter, it had depth, and life followed. Tiny invertebrates were the first animals to step onto land. Millipedes and springtails crawled through the moss, feeding on decaying plants. Soon came spiders and scorpions, hunters in miniature, perfectly adapted to their new environment. Eventually, some brave fish began to venture into shallow streams and muddy wetlands. They developed stronger fins, primitive lungs, and sturdy ribs. Over time, these features evolved into legs, lungs, and limbs, and so the first amphibians appeared. They were clumsy at first, half fish, half frog, but they had found a new world, one rich in plants, insects, and space. With time, these creatures would give rise to reptiles, mammals, birds, but all of it began here, with the mosses and trees that dared to green a barren earth. The land was no longer silent. It rustled with leaves, it buzzed with insects, it pulsed with life. As you rest now, imagine standing in one of those ancient forests, the air damp and heavy with the scent of ferns. Towering club mosses loom above you, casting long shadows across a swampy floor. Strange insects buzz past your ears. Somewhere in the distance, a primitive amphibian croaks at dusk. This was our planet's awakening, and it's only just begun. Next, we'll wander through the Age of Giants, when Earth became a land of titans and the footsteps of dinosaurs echoed across its soil. Chapter 6: The Age of Dinosaurs, Earth's Great Dynasty. The forests were vast now. The skies were blue, the continents drifting slowly toward their modern shapes. The air was thick with oxygen, and the land teemed with life. Yet something ancient stirred beneath the ferns, something that would define Earth's next chapter. The dinosaurs had arrived. It began modestly, around 230 million years ago, in the late Triassic period. The earliest dinosaurs were small and nimble. Some walked on 2 legs, others on 4. They were predators and herbivores, scavengers and survivors. Not yet the thunderous giants we imagine today, but adaptable, fast, and destined for greatness. Then came a mass extinction. Volcanic eruptions poisoned the air and warmed the seas. Many competitors perished. and in the ecological vacuum that followed, the dinosaurs rose. Through the Jurassic and Cretaceous periods, they spread to every continent. Their diversity exploded. Some grew towering and massive. Others remained small and feathered. The Earth was their kingdom, and they ruled it for over 160 million years, far longer than humans have yet existed. Imagine walking through a Jurassic Valley. To your right, a Diplodocus grazes, its neck like a living bridge stretching through the trees. It moves slowly, each step a gentle quake in the earth. Ferns brush its flanks, and the sunlight filters through its massive frame. Above, in the canopy, pterosaurs, not true dinosaurs, but their airborne cousins, glide on leathery wings. Their calls echo across the valley, blending with the rustle of ancient leaves and the buzz of insects the size of your hand. Suddenly, the underbrush stirs. A stegosaurus lumbers through, its plated back shimmering in the sun. Its tail sways, tipped with deadly spikes, more for show perhaps than war. It doesn't notice you. You are a ghost in its world, observing quietly as Earth dreams its ancient dreams. And not far off, you hear the chirping of small feathered creatures. Contrary to old beliefs, many dinosaurs were not scaly, but feathered, warm-blooded and swift. Some scientists now argue that birds are not descendants of dinosaurs, but dinosaurs themselves, living, breathing remnants of that ancient lineage. Yes, the robin on your windowsill, a cousin of the velociraptor. But not all dinosaurs were peaceful. There were hunters, masters of sight, scent and speed. The Tyrannosaurus rex, with teeth like steak knives and a jaw that could crush bone, was not the largest predator ever, but perhaps the most iconic. Yet even T-Rex had limits. It lived only in the late Cretaceous and shared its world with armoured ankylosaurs, crested hadrosaurs and horned triceratops, who likely travelled in herds across the ancient plains. These ecosystems were rich and varied. Some areas were dense jungles, others dry plains, some coastal lagoons filled with marine reptiles, like the mosasaur and plesiosaur. Though not true dinosaurs, these aquatic creatures ruled the seas with grace and ferocity. It was an age of giants, but also of complexity. Dinosaurs were social. They nested. They cared for their young. Some may have migrated seasonally, using memory and instinct to find ancient breeding grounds. And then it ended. Chapter 7. Extinction and Silence. The day the sky fell. It was just another day. The air was warm. Forests rustled under a late Cretaceous breeze. Giant turtles swam in freshwater rivers. Triceratops herds grazed near shallow lakes, unaware that, above them, a rock the size of a city hurtled through space. 66 million years ago, an asteroid, more than 10 kilometers wide, slammed into what is now the Yucatan Peninsula in Mexico. The impact unleashed energy equivalent to billions of atomic bombs. The sky turned to fire. Forests ignited. Shockwaves flattened everything within hundreds of miles. A towering tsunami swept across the coasts. Then came the darkness. Ash and soot filled the atmosphere, blocking out the sun. For months, perhaps years, Earth was plunged into a freezing twilight. Photosynthesis halted, plants died, herbivores starved, predators soon followed. This was the Cretaceous-Paleogene extinction event, the fifth mass extinction in Earth's history. It wiped out nearly 75% of all life, including the non-avian dinosaurs, ammonites, flying reptiles and marine giants. But not everything died. Some mammals, birds, insects and small reptiles survived, those who could burrow, fly or adapt quickly. In the silence that followed, these survivors inherited a wounded Earth. The dinosaurs' reign was over, but their bones remained, and in time their legacy would awaken again, this time not as rulers of jungles but as fossils uncovered by curious minds. Children would marvel at their names. Paleontologists would piece together their stories. Artists would breathe life back into ancient forms. And the Earth, ever patient, turned a new page. For though extinction brings silence, it also creates space. A clearing in the forest, a new dawn. In this cleared stage a new lineage began to rise. Not with roars or feathers, but with soft fur and watchful eyes. The age of mammals had begun. Chapter 8. Fur, Fire and Footsteps. The Rise of Mammals. In the shadow of the dinosaurs, mammals had lived quiet lives for over 100 million years. They were mostly small, nocturnal, and unassuming, like shrews with twitching noses and clever paws. But they had a secret. Warm blood, fur, and flexible brains. And now, with the giants gone, they had room to grow. Over the next 10 million years, Earth began to warm. Forests returned, grasses evolved, and mammals diversified, adapting to every niche. Some stayed small, others grew large. Hooves, claws, flippers, and wings all appeared. The oceans, once ruled by marine reptiles, now welcomed whales and seals, descendants of land animals who returned to the sea. In the skies, bats took flight, the only mammals to truly master the air. On land, strange creatures evolved. Giant ground sloths the size of cars, titanotheres, like hornless rhinos with massive bodies, early elephants with spiral tusks. Some grazed the open plains, others hunted in packs, using intelligence and coordination to outwit prey. And among them, primates, small tree-dwelling creatures with grasping hands and forward-facing eyes, began their slow climb towards something extraordinary. They evolved in the trees, leaping from branch to branch, navigating complex environments. They developed social bonds, problem-solving and long-term memory. Their brains grew larger. Their curiosity deepened. Among these primates, a branch appeared that walked upright. They left the forests, they explored the savannas, they made tools, they remembered, they told stories. The Earth had never seen anything quite like them. But we'll come back to them soon. For now, let your mind drift to those ancient plains where giant mammoths roamed under Ice Age skies and saber-toothed cats waited in the brush. Hear the thunder of hooves, feel the wind of a warming world, smell the damp earth, alive with possibility. This was the prelude to humanity's story. The final act of prehistory was about to unfold. Chapter 9. The Dawn of Humans, Sparks in the Savannah. The Earth grew cooler once more. Around 7 million years ago, ice crept down from the poles, reshaping forests into open grasslands. Trees thinned, rivers changed course, and new pressures shaped the animals that lived among them. From within this transforming landscape, something new began to emerge. They weren't human, not yet, but they walked on two legs. Their hands were free. They could see farther across the plains, reach higher, carry more. Their brains, though still small, began to hum with potential. They were our ancestors. Australopithecus, meaning southern ape, is one of the earliest known hominins. Imagine her walking across the African savannah, upright, cautious, aware. She gathers roots, watches the sky, shields her eyes from the sun. Her child clings to her hip, and in her mind something flickers. Memory, strategy, instinct, and slowly a sense of self. By 2.5 million years ago, the first members of the genus Homo appeared. With them came a revolution, not of size, but of mind. They shaped stone tools, not merely picked them up, but crafted them, chipping away flakes to make sharp edges. With each improvement came survival, and with survival came time. Time to grow, to think, to dream. They began to migrate. Out of Africa they spread to the Middle East, Asia, and eventually Europe. These early humans faced ice, predators, and the vast unknown. But they adapted. They used fire. They built shelters. They buried their dead. The Neanderthals arose in Europe, strong, skilled, and capable of symbolic thought. In Asia, the Denisovans lived quietly, their legacy hidden in our DNA. Meanwhile, in Africa, Homo sapiens, our direct ancestors, were developing something powerful, language. With language came shared memory. With memory came culture, and with culture came stories, passed from mouth to mouth, generation to generation. The world had changed many times before, but now awareness itself had evolved. Chapter 10. The Rise of Culture, Firelight and Paint. Close your eyes, picture a group of humans, perhaps 40,000 years ago, gathered around a crackling fire inside a cave. The flames dance against the stone walls, casting shadows that seem to move with life. In the dim light, someone begins to paint. Not with random smears, but with intent. Ochre, charcoal, and mineral pigments are carefully applied. The image of a bison emerges, muscular, in motion. Next to it, handprints like signatures across time. This is not just art, it is meaning made visible. The caves of Lascaux, Chauvet, and Altamira hold these stories, echoes from minds not unlike ours. They speak of animals, hunts, spirits, and perhaps dreams. Some scientists believe they were ceremonial spaces. Others think they were classrooms. Perhaps they were both. Humans were not merely surviving, they were remembering. They tracked the stars, watched the seasons, planted seeds, domesticated animals. They gave names to rivers and hills, told myths of thunder gods and forest spirits. The planet was alive, and so were their imaginations. Fire became central, not just for warmth and food, but for gathering. Around firelight, language flourished. Elders shared wisdom, children listened wide-eyed. Ideas passed from one heart to another, fusing individual lives into a shared identity. Soon, symbols appeared. The earliest scripts carved into bone and clay. These weren't full alphabets yet, but markers of trade, seasons, lineage. A soft murmur of written memory, and humans kept moving, across deserts, over mountains, through jungles, to Australia by raft, to the Americas over ice and land bridges. Each migration added to the tapestry of prehistory. The earth was mapped by foot, memory and myth. And as the glaciers receded again, something else emerged. Something vast and permanent. Civilization. Chapter 11. The First Cities from Mud to Marble. As the ice sheets melted for the last time around 12,000 years ago, the planet stabilized into the gentle warmth of the Holocene epoch, our current geological age. This moment, quiet in cosmic terms, allowed something rare: settlement. People stopped wandering and began to farm. The Fertile Crescent in Mesopotamia became one of the cradles of agriculture. Wheat, barley, lentils, plants once gathered wild, were now cultivated. Animals too were domesticated. Goats, sheep, cattle, and dogs joined the human story. With food came surplus, with surplus came community, and with community came the first cities. Çatalhöyük in modern-day Turkey, Jericho in the Levant, and later Uruk in Sumer all rose from the soil. Mud brick houses, narrow alleyways, communal ovens and granaries lined the landscape. Trade networks stretched for hundreds of miles, linking obsidian mines to river deltas. Humans built temples, dedicated to gods of rain, sun and fertility. They honoured the dead with burial mounds. They sculpted idols. They built walls, not just for defence but to define sacred space. Societies grew stratified with priests, artisans, farmers, and rulers. Early systems of law and governance took shape. Writing evolved from symbols to full scripts. Cuneiform, hieroglyphs, Proto-Sinaitic. And so, history began. This was the end of prehistory, not because humanity had changed overnight, but because we'd begun to record our own existence. The veil of forgetting had been lifted, yet the echoes of prehistoric Earth never fully disappeared. The stones of ancient monuments, the DNA in our cells, the myths we still whisper carry the memory of a time before timekeeping, before kings and kingdoms. A time when humans listened to the stars, danced under the moon, and walked barefoot across an untamed Earth. Chapter 12. The Memory of Earth. A Soft Goodbye. And now, dear traveller, we've arrived at the edge of deep time. From molten beginnings to microbial life, from trilobites to tyrannosaurs, from shrews to shepherds, Earth has spun its tale in silence, until we came to listen. Even now, when we stand under city lights, scroll through glass screens and launch satellites into orbit, we remain, at heart, creatures of prehistory. We are dreamers born from stardust, walking upon a crust shaped by ancient fire. Inside your bones is calcium forged in the sea. In your breath, oxygen from ancient cyanobacteria. In your heart, the beat of ancestors who stared at the same moon and wondered who they were. Prehistoric Earth is not gone, it lives in us. In the way we huddle together for warmth, in our awe of mountains, our fear of thunder, our love of stories. It echoes in lullabies and legends, in symbols carved into stone, in the soft hush of waves meeting sand. So, as you lay here now, wrapped in quiet thought, know this. You are the dream of 1 billion years, a breath held by Earth for eons, and now gently released. Let your thoughts drift like pollen on an ancient breeze. Feel the ground beneath you as a living memory. And if your mind stirs once more, let it wander back through fern-filled valleys, under Cretaceous stars, through mammoth-haunted ice, and back to that first spark, when life opened its eyes and saw the sky. You've journeyed through time tonight. Rest now. The Earth remembers, and so do you. Good night, dear listener.